Assalamu alaikum. I am Dr. Nesrine Benarous, teacher at Constantine I University. Today I have the honor to present you a part of my work entitled Synthesis, Crystal Structure, Hirschfeld Surface Analysis and Biological Properties of New Benzylidene and Aniline GIF-basis Derivatives. To introduce our work, I will present generalities on the application of Schiff bases, as well as the synthesis of anthranilonitrile Schiff-based derivatives. Afterwards, I will present the single crystal X-ray diffraction of the three compounds. After that, I will present the Hirschfeld surface analysis, followed by the biological evaluation of the new compound. And I will end with conclusion. Thanks to their relatively simple preparation methods, Schiff bases have a wide and constantly expanding field of applications. Indeed, they are involved in several organic syntheses, and they also enter in the preparation of coordination complexes. They have been used in magnetism, luminescence, corrosion, and catalysis. Also, they have been used in the biological field due to their potential pharmacological and medicinal properties. We chose the anthranilonitrile because it has interesting properties. In particular, derivatives of this compound are good candidates for their anticonvulsants and anti-Alzheimer properties. In our work, 3 new Schiff bases were prepared. In fact, the condensation of anthranilonitrile and 2,6-dichlorobenzaldehyde led to the preparation of 2 compounds, 1 and 2. However, its reaction with 4-nitrobenzaldehyde led to the preparation of 3. The condensation of compound 1 and 3 were carried out by reflex, whereas compound 2 was obtained by the solvothermal method. Now, I will present the single crystal X-ray study of our new Schiff bases. The crystal structure of our Schiff base have the same skeleton, 2-benzylidene amine benzonitrile, with different substituents, 2,6-dichloro for compound 1 and 2, and 4-nitro for compound 3. In the crystal of 1 and 2, the molecules are linked by CHN and CHCl hydrogen bands. However, the molecules of compound 3 are linked by CHN and CHO hydrogen bands. As we can see in these figures, each structure arises as 2-dimensional layers. The first one, founded by R2210 and R2216 ring motifs and the C3 infinite chain. The second one is based on R2210 and R4422 ring motifs, while the structure of compound 3 is formed by an alternation of rings with R227 and R216 motifs. The crystal structures are enhanced by CCl-pi interactions for the first compound and by pi-pi interaction for compound 2 and 3. In addition, the presence of chlorine atoms in 1 and 2 generates another type of interaction, which is halogen-halogen. The third part of our work is the study of intermolecular interactions by Hirschfeld surface analysis. The Hirschfeld surface was used to quantify the various intermolecular interactions in 3 compounds. The view of the Hirschfeld surface mapped over the norm show the white surfaces indicating contacts with distance equal to the sum of van der Waals radii, and the red and blue colors indicate distance shorter or longer than the van der Waals radii, respectively. A map of the shape index showing or touching red and blue triangles, which indicates the presence of intermolecular pi-pi interaction in compound 2 and 3. This also evident from the presence of flat regions mapped over curvedness. The overall two-dimensional fingerprint plot indicates that the most significant contacts for compounds 1 and 2 are CLH, HH, NH, and CH. However, in compound 3, the most significant contacts are HH, OH, NH, and CH. The difference between them is due to the presence of different substituents. The fourth part of our work is the study of the biological properties of the new Schiff bases. The antibacterial activity of our compounds was carried out using the antibiogram by diffusion method, which allows us to determine the lowest concentration that inhibits any visible growth of a given bacterial strain after 18 hours of incubation at 37 degrees. We tested our compounds on 4 bacterial strains. The comparison of the MIC of each bacterial strain and for each compound indicates that the Schiff base derived from 4-nitrobenzaldehyde has the more significant antibacterial activity compared to that derived from 2,6-dichlorobenzaldehyde. The other biological test carried out for our compounds is the in vitro cytotoxicity. This test was carried out using Artemia selena larvae. To study the concentration-mortality relationship, we often use the lethal concentration, which causes the death of 50% of the larvae. LC50 is inversely proportional to the cytotoxic property. The degree of toxicity of our Schiff bases was evaluated from this table and indicates that compound 1 with the LC50 of 44.19 microgram per milliliter is more toxic than compound 3. In conclusion, 3 new Schiff bases were prepared and characterized by single crystal X-ray diffraction. The intermolecular interaction in the crystal structure were quantified using Hirschfeld surface analysis, which indicates that the most significant contacts are CLH, HH, NH, and CH for compound 1 and 2, and HH, OH, NH, and CH for compound 3. The evaluation of the biological activity of our compounds shows that the antibacterial properties are related to the presence of the nityl group in compound 3. However, compound 1 with chlorine atoms is more cytotoxic. Thank you.